My name is Chris Impey. I'm a professor of astronomy at the University of Arizona. And I wrote a book about astrobiology, the search for life in the universe, called The Living Cosmos. Astrobiology is not my research field. I work on cosmology, the study of distant objects in the universe. In fact, objects more than 1 billion light years away. But I'm very interested in the idea that we may not be alone in the universe and that we might find life elsewhere. To me, it is one of the big unanswered questions in science, not just astronomy, but in all of science. In this book, for a part, I have to look at what happened to life on Earth and the story of this planet. Because understanding life elsewhere in the universe, we still only know of life on one planet. We must understand life on Earth as well as possible. One thing we learn in the history of life on Earth is that life formed very quickly on this planet when the planet was very inhospitable and the conditions were very extreme. But in the book I talk about how extreme might be life's middle name, because life can be inside rock, can be hotter than the boiling point of water and colder than the freezing point. A life can be found in complete darkness, in caves, or at the bottom of the ocean. And if life can be found in such strange and extreme places here on one planet, then we think that there are other strange and extreme places where life might also be found. So it's important to know the edges of life on this planet to be able to say what we might find elsewhere. Also, we have to look at how evolution happened on this planet. For most of history of life, life is tiny. Everything for the first 3 billion years is microscopic, nothing bigger than the small nail of your finger of your hand. For 3 billion years. So we are interested maybe in finding life like us, big creatures, animals with brains. But we must recognize that on Earth most life is microbial or microscopic. And that might also be true in life elsewhere. Then I look at the issue of what we can do by looking out in space. Our immediate environment is the solar system. So the distance between stars is very large. Travel to the nearest stars will take maybe hundreds of years for us. So we must also learn about our own solar system. Most people think that the Earth is very special, that it's the only place with life in the solar system and maybe beyond, because the temperature is just right, there's a lot of water. But if life just needs energy and water and organic or carbon material, then we can find that in other places in the solar system. I talk in particular, of course, about Mars because it's of great historical interest for life. But Mars is a difficult place, very cold, very dry. If life exists on Mars, almost certainly it's not on the surface, but maybe underground, maybe deep underground in places we cannot dig with the kind of small spacecraft that we send to Mars. So Mars may frustrate us in the search for life. Astronomers are very excited by 2 other places in the solar system. Europa, a moon of Jupiter discovered by Galileo, because that is a water world, completely covered in ice, and under the ice almost certainly liquid ocean. And with so much water and some energy that comes from the middle of the moon by radioactive heating, there is the possibility of life. And also Titan, a large moon of Saturn. One of the things that astronomers realize is that the moons of giant planets are just as interesting as planets in the search for life, because a large moon can have energy, can have an atmosphere, can have all the right conditions. Titan we visited very briefly about 5 years ago, and it has a nitrogen atmosphere thicker than the air we're breathing, and it's a sizable moon. It has ethane and methane on its surface in liquid form. There are lakes, there are rivers, there's weather there, there's geological activity. So if there's life on Titan, it may not be the same as Earth life, which would be very exciting. Astronomers are interested in life however they find it. But one big question is life elsewhere the same as our life, the same DNA, the same biochemical basis, same genetic code, or can life form in different ways? Different genetic code would be a small difference. Larger difference might be it doesn't use water. Very large difference would be that it doesn't even use carbon, but uses some other chemistry to make information. So after talking about the solar system, I move into the outer universe further from Earth, and the exciting discovery starting in 1995 that we can find planets beyond the Earth. So until 1995, we'd looked very hard, but the only planets we knew were the solar system. If you look on the web right now, you would see 450 planets, a huge number, all discovered in the last 15 years. So this activity is now very successful, and we think almost every star like the Sun will have planets around it. But finding planets far away is hard, and so we find the easy ones, the big ones first. And almost all of those 450 planets are like Jupiter, or maybe like Uranus or Neptune. And those are gassy planets that may have rocky cores, but they're unlikely to host life. So we found many planets beyond the Earth, but most of them are not likely to be habitable. But that's just because we're beginning. The current record for a planet is about 2 times the Earth's mass, and we only have a very small number that are Earth-like. But in the next few years, we expect to find Earth-like planets, twins of the Earth, maybe 10, 15, 20 light years away. And those will be the best places to try and look for life. That's a difficult experiment, and the way astronomers will do it is by looking for chemicals in the atmosphere of those planets that indicate life. If you were far from the Earth, looking at the Earth, and you made a spectrum, you would see water vapor, and if you saw oxygen and ozone, those 2 ingredients are very difficult to sustain without biology. And so we will look for those same chemical ingredients on distant planets to look for the traces of life, microbial life. So that activity is very prominent now for astronomers, and most people think in the next 10 or 15 years we may find planets with life imprinting in their atmospheres. And then in the last chapter of the book, I talk about the search for intelligent life in the universe. It's most likely that most life elsewhere will be microbial, since most life on Earth is microbial, and for most of Earth's history, life was bacterial. And so we expect microbial life elsewhere. And maybe the public or in general, people are not as interested in finding microbes or bacteria somewhere else. But they would probably be very interested in finding intelligent creatures of some kind. So another set of astronomers using different methods is trying to listen for signals from other planets, faraway planets, artificial signals that indicate technology and some civilization, some intelligence. This has been going on for 50 years without success. Now most people, if they did an experiment for 50 years and failed, would give up. But these people do not give up because they just think the question is so important, we have to keep asking the question. And they also think that since their search depends on computer technology and the power of microprocessors, that the search is getting better every year because of our computers. And so now they think the search is very powerful, and now that it might succeed. If it doesn't succeed after 10 or 15 years, they will probably conclude that intelligent life or civilizations are quite rare in the Milky Way. Of course, if it does succeed, it will change everything, because many people think the discovery of an intelligent civilization will redefine how we view ourselves and our place in the universe. Some people think we might even not want to know the answer and we shouldn't do the search. Stephen Hawking recently was quoted as saying we should not search because it could be dangerous for us to find an advanced civilization. I don't agree with that. I think we should search. But again, the odds of success are very hard to estimate. So in this subject, to conclude, I think that even though we only know of life on one planet, the expectation is there that the universe is made for life, that the habitats for life are there, the ingredients for life are there, the universe is a big place, and it would be very surprising if there's not life elsewhere. The reader for my book is not a scientist, but somebody who's interested in science, who's maybe heard of some of these ideas and wants to read more. So the book is not technical, no equations. It's written for every person to read. It includes different kinds of science too, some biology, some chemistry, some astronomy. Astrobiology is an interesting subject because it is interdisciplinary and includes many types of science.